Okay, we're going to talk about streaming beyond the desktop. So my name is Alex. I'm a manager for the Amazon CloudFront product. I'm responsible for software development, product management. A lot of my customers try to use CloudFront to reach video to different mobile devices, or different devices, I guess, beyond the desktop. Set-top boxes are certainly included, mobile devices, PCs, you name it. And so I want to do today 4 things. First, I want to go through some of the challenges that I see customers struggling with as they try to do that. Second, talk briefly about the traditional approach there. And then third, go through some best practices that we see customers doing, whether or not they're using AWS or CloudFront. Fourth, we'll talk about AWS specifically. And then I'm going to get out of the way and turn things over to Ivan from Vivo, who will talk about his experience using CloudFront and AWS in order to reach devices beyond the desktop. And we're going to be on, oh, there we go. One of the advantages of going late in the day, I should say, is that a bunch of these things have been covered already. So there may be a couple of instances where I'll move quickly through something because you've heard it from John, or you've heard it from Usman, or you've heard it from one of the other presenters. But let's go ahead and get started. It's a complex environment out there. There are many different devices. These devices expect different delivery protocols. These devices expect different codecs. And it leaves our customers saying, hey, how do I do this? All I want to do is reliably and scalably get my video to a bunch of platforms that my customers might use. If we just look at the mobile phone market, the plethora of devices that exist out there really create challenges for content distribution. iOS devices, they support only HLS. Android devices, vendor-specific protocols. So it's not always the same for Android. One device may expect one format, another device may expect another. Windows Phone, Xbox, I guess this is the mobile phone case, so Windows phones expect smooth streaming. And there are new devices coming into the market almost every month. So let's talk about some of the areas where we see challenges. One is in transcoding. So David this morning talked about the different transcoding options that are out there on the Amazon platform and beyond. But we need to manage both the codecs that a device expects and the different bit rates and formats that different screen sizes require. Usman talked about security models. For video specifically, there are choices around different players. When do I take advantage of the native player? When do I take advantage of third-party players? For security, it's questions like, do I use DRM? Do I use tokenized security? Do I do a little bit of both? So we'll go through that. In terms of measurement management, basically getting you the visibility that you expect into your content, we tend to think about 3 different things. One is monitoring. What is the viewer experience? What is the business impact of what I'm doing? Identifying trends. Which devices are working well? Which devices aren't? Where do I need to focus on optimization? And then reducing things like defects in the viewer experience, reducing turnaround time to distribute content, reducing your operational costs. So let's talk about the traditional media streaming solution. We used to see a lot of customers basically running separate parallel stacks for different devices. So they might run one stack that addressed the iOS platform, another one to address Android devices, and a third one to address Windows devices in this example. And except when they didn't want to incur the cost, they would make a tough decision. They would say, let me give up on the Windows Phone. It's a small percentage of my market. I'm going to focus on Android and iOS. And OK, that's a reasonable decision because it saves you money, it saves you operational complexity, but it means that there's some number of your customers who are unable to access your video. So let's look at some best practices that help you out of that situation. I wish this was here's the answer. It's not one answer. It's a series of answers. And in fact, what I'm going to do is take you through 6 different best practices. 3 of them have a fairly clear-cut answer. The last 3 are more things to think about, things to consider where the right answer may depend on the specifics of your use case. So Encoding. David talked a lot about this in the beginning of the day. There is an emerging common denominator that most devices can handle on an encoding perspective. So H.264 video with an AAC audio track will work on almost all devices. So in terms of things to consider, that's a good foundation for a encoding platform that will reach multiple devices. Now, that's not going to end up with one copy of your asset. You're still going to have multiple copies of your assets to reach different bit rates, different form factors, and it's also not going to solve the delivery protocol problems. But take advantage of the commonality that H.264 with AAC provides in order for you to get an encode that is broadly applicable as opposed to separate ones for separate devices. Second, John talked a lot about this morning. Don't store your content in multiple places when you can store it in one. Avoiding storage duplication is, I think, one of the easier things that you can do, whether it's on AWS or another platform, in order to make your lives easier when trying to reach multiple devices. So AWS offers a lot of different storage options that will allow you to have that right mix of central location storage with archival backup that will allow you to reach multiple devices. Third, near and dear to my house, use a CDN. CDNs are really the right thing to distribute your content if you need global reach, if you need high bandwidth, sort of high bit rates, if you need low latency, if you need access logs to generate data into what your customer is doing. This is what CDNs do. CloudFront is one, and I'll talk a lot about that later. But content delivery networks are really a key piece of the way to scale your delivery to multiple mobile devices. Now let's go into some things where there isn't a right answer, and it will depend on the nature of your use case. Players. There are native players built into each of the platforms you're trying to reach. In some cases, those are the right things for the job. They're turnkey. They're very easy. Sometimes they're the only option that you really can have. There are also third-party players that are out there that will give you some more consistency, ability to customize, ability to collect more data about your end user's experience. So look at your use case. Try to understand what you're trying to accomplish with your video and use that to weigh off the ease of implementation that is provided with a native player versus some of the flexibility and configuration options that are available with a third-party one. Securing your assets. Usman talked a lot about this in his presentation. Basically, there are three schemes that we see different customers choose. Some customers will choose to pre-DRM their assets. So basically, apply DRM at the in a step in headquarters, if you will, between encode but before delivery. That works really well for popular content. For less popular content, we see some folks doing DRM on the fly. And so I'm going to keep my asset non-secured in my controlled origin, and then only DRM it when it is actually played. If you have a long-tail catalog where there's not a certainty that each piece of content will be watched multiple times, this can be a way to reduce your cost because you're not going through the computational load of DRMing assets that may never be watched. And then third, Usman talked a lot about our CDN private content feature. This can be used either independently or in conjunction with a digital rights management system, but basically making sure that the URLs that you vend to your customers are only played by the devices that you're trying to target. Measuring viewer experience, two best practices here. This is hard. This is really hard for video, and it's especially hard for video across different devices. So the overarching best practice is to take multiple views at the end user experience. We like to see customers, when they combine a CDN view, sort of let me look at the server-side view of data that's coming out of the CDN, with a client-side view that shows the end user experience that customers are actually seeing. So in this example here, we have instrumented a client to look at the number of sessions that are getting a rebuffering event. So looking at once I start playing the video, how frequently does it play until the end? That is a metric that you can only get from the client side. You can also look on the server side at things like average bit rates. So how often am I delivering the highest bit rate content that I have available? Combining the server side and the client side view gives you that full picture of your end user's experience. So let's go through now and talk a little bit about how AWS has implemented some of these best practices. The first thing I would call out is that it's not just AWS. It is also the ecosystem of partner solutions that run in AWS. So S3, Elastic Transcoder, CloudFront, these are all solutions that have great applicability kind of out of the box for video and video streaming beyond the desktop. But there are also some great partner solutions available in the AWS marketplace to do things like run a streaming server or secure your content. So these things work in conjunction with AWS infrastructure in order to create more options for you as customers. Second, we've talked a lot about this all day. Pay-as-you-go pricing, capacity when you need it, global delivery. Usman just showed you the picture of CloudFront's global delivery. This is really what we do here at Amazon. And then third, we just, again, heard about the MPAA security best practices. I won't go into that again. Elastic Transcoder, we talked about encoding to take advantage of commonality amongst devices. Elastic Transcoder is a great way to do this. So as David said this morning, starts and ends with Amazon S3. You create put your mezzanine asset into Amazon S3. We have presets available for the common mobile devices. So you can say, hey, let me do one that is going to look great on an iPhone 5 or another one that looks great on a Kindle Fire. All of those are there. It's very easy to onboard your content quickly, reduce your storage cost, and basically create less content management overhead. Storing and managing your media assets. John talked this morning about these as well. As Amazon S3 provides internet scale storage, it's a great place to use your origin server. Amazon Glacier gives you a great place to archive your content, and the storage gateway gives you a great way to get it in and out. Now let's talk about video streaming through AWS and CloudFront in particular. This is kind of a complicated picture, but I guess the thing to take away is that the architecture that you choose will depend, in part, what type of streaming you're trying to do. So on the center of this diagram here, we have a user trying to stream static content, video on demand content, using a combination of Amazon S3 and Amazon CloudFront. So a customer would store the original copy of their asset in Amazon S3 and then use CloudFront to distribute it to end users. On the right, we have a live video dimension, where a customer might be streaming a live video into an Amazon EC2 instance and then again using Amazon CloudFront to deliver it. What you can do with CloudFront, what you can do with AWS to stream video, we support all of the major HTTP-based delivery protocols. So HLS, which is Apple's HTTP live streaming, HDS, which is HTTP dynamic streaming from Adobe, smooth streaming, and MPEG-Dash. These are probably the 4 ones that you hear the most about. All 4 of those you can do using CloudFront. There are caching optimizations that we've built particularly into our network that make sure that the object your end users are looking for, the videos your end users are looking for, are available when your end users want it. CloudFront scales. It has global reach. There's a great native streaming support story when you combine Amazon Elastic Transcoder with Amazon CloudFront. And there are a lot of partner solutions available from the media ISVs. Usman talked about this. Two of the major ways that customers use CloudFront to secure their content. One is the private content feature. So basically, this allows you to create a policy that says, when is it OK for my end users to view this video? It can be anything from, this video is good for the next hour, or it can be this video is only viewable from this particular IP address. There are also a variety of different content encryption options available in the AWS marketplace. Measuring and monitoring the end user experience, we talked about this earlier. What we see customers doing with AWS that's pretty neat is combining logs from your video player with CloudFront access logs and processing the combined logs together using Elastic MapReduce. This creates a really good way of quickly and economically getting a full 360-degree view of how your customers are viewing your content. And that's quickly the overview. I think that it's best to really turn things over to Ivan here. So Ivan is going to come up and talk about how that is done in practice. So thank you, Ivan.
Hi, guys. Hey. There we go. So thank you for coming out and taking the time to hear us out today. And thank you, Alex. You laid out a lot of pertinent points that are really challenges that we face in the media industry every day when working with video delivery. So a little bit about myself. I am the Director of Systems Engineering at Vivo, so I'm responsible for the infrastructure and architecture and video streaming and CDN. And a little bit of context about Vivo. So we're a premium music video platform. Basically, we provide official music videos straight from the record labels and distribute that on our own owned and operated platforms as well as our syndication platforms. And some context on some statistics actually. In August 2013, we did 4.4 billion video views worldwide, and about 28% of those were coming off of mobile devices. And in that same time frame, about 250 million unique visitors worldwide. And we have a catalog, it says 75,000, but it's very rapidly approaching 100,000 videos from over 21,000 different artists. So some of the challenges that we have to deal with are providing a cohesive experience to all of our users across various different platforms. And as Alex alluded to, there's so many different devices and streaming protocols to account for when dealing with video and mobile devices versus connected devices. It could become a bit of a headache. And it's really important to be able to adapt and penetrate these new markets and be on new devices as soon as they become available and really be able to take advantage of these types of business opportunities. So up here you have a slide that covers all the platforms that Vivo is currently on. We're on the web where we do dynamic streaming over RTMP. We do HLS video streaming on iOS devices like iPhone and iPad, Apple TV. Just yesterday morning, we launched our Samsung TV app on Samsung televisions and Blu-ray players. On Roku, we do HLS as well. And then there's a contingent of platforms where we do smooth streaming, mostly Microsoft-based, obviously, Xbox, Windows Phone, Windows 8. And we do progressive media download on Android and mobile web as well. And last but not least, we have a live Vivo TV linear channel that really aims to recreate the music television watching experience, and that is actually transcoded and repackaged on the fly and served out over RTMP, HLS, and Smooth. So as you can see, it's a lot of different platforms, and each one of those 75,000 assets is actually encoded 35 different times to cover all these different assets. And that's why you can see that it becomes a big operational overhead to be able to serve that content out on all these different platforms. So right now, all of our encodes are adaptive, with the exception of Android and mobile web, but we're working towards rectifying that and bringing down one video to 35 different renditions down to 18 by the end of the year. And we're trying to achieve that through the broader use and adoption of HLS and smooth streaming protocols. So with HLS, our approach was really to find the least common denominator for your video encoding settings. So even within HLS itself, there's so many different variations, so to speak, or different implementations of it. Even within, the Apple ecosystem itself, there's some features that, work better or not at all versus on some certain devices. Roku handles HLS in its own certain way. So, there's a little bit of fragmentation there in terms of what type of support you have for things. But the one thing that you do have control over is, picking the right lightweight options and manipulations that you can do to still serve that content through one unified set of encodes. And the real thing that I want to stress here is to try to have as many repeatable workflows and practices as you can. That and Amazon's great, but we try to architect things at Vivo that in such a way where it's agnostic to a particular service provider. So hypothetically, you can have things running in multiple different cloud providers, and in certain instances we do. Okay. Oops. So with our HLS manifests, right, like the whole goal is to get the same adaptive bitrate encode on as many different platforms as possible and to reuse them. So some of the things that you can weigh against each other are the startup time of a video, versus the types of devices that you're serving the content out on. So you may be using HLS video on a mobile cellular platform, but then you can also use those same encodes on connected devices. And you can kind of do these type of things by manipulating the manifest, but they still have the same underlying video encode. So on an iPhone with a 3G connection, you might start with the manifest at 500 kilobits per second. But on a connected device, same set of encodes, we want to start at a much higher quality level. And with video streaming, it's you see the trend more and more now. It's good to move towards a purely HTTP-based protocol where possible. And the reason for that is there's other associated costs with FMS servers and licensing and things like that kind of limit your options in what you can do, the type of scale, and really the cost involved in that. And with adaptive bitrate protocols, you really get the benefit of faster startup time. So, as an example, our HLS encodes can start as low as a 64K only audio stream and scale all the way up to a 4.5 megabit video encode that would look great on an 80-inch television, let's say. And with video streaming, like at Vivo, we use a multi-CDN vendor approach, but it's not quite right for everybody. So you really have to take a look at your footprint and weigh the pros and cons of the extra reliability, the ability to protect against regional outages or traffic. Premier League soccer in Europe at one particular ASN may be struggling, whereas another is not. Right? Being able to protect yourself from those types of issues versus the overhead that comes along with having multiple CDNs. So I mean, it does have a lot of pros, but there are also drawbacks that you really have to consider when making that decision. So I'm going to talk a little bit about our encoding workflow itself. So the encoding workflow that we deploy at Vivo it's actually kind of very similar to the elastic transcoding service that was talked about earlier, but we have things set up in a queue-based system where there's a series of tasks. So one of the first tasks is a request task. So when a content provider or the record label ships us a music video, we ship that off into the cloud, and then the next step in that process is the encoding job itself, right? So for that one video asset, we create the 6 or 7 different platform jobs for that video's encoding settings. So once that job moves past that step or phase in the encoding process, we then move on to delivery, where it gets uploaded. The output is uploaded to our different CDN partners, and finally we update our data layer in the backend for access to playback. And here's a little diagram that kind of breaks down. On the top, you see the different queues and tasks, and then the worker nodes involved that pick up those tasks. So the benefits of this type of system is that it's stateless. So when you have a failed task, you don't have to really worry about it because it'll go back to the queue and then another worker node will pick up that message. And it's definitely scalable. So we have the advantage of being able to scale our fleet horizontally. On a regular day, we might only have maybe 10 or 15 video encoders going. But then when we have special projects or a bulk ingest of content, where we bring on a new record label or content provider, and now all of a sudden we have to ingest and encode 20,000 videos in a very short period of time, we're able to spin up literally thousands of worker nodes to attack those queues and get it done pretty quickly. And last but not least, it's a very maintainable system where the workflows are very repeatable. Like there's no real deviations to any of them. They always repeat in the same fashion. So some of the video encoding settings that we deploy, we encode multiple different bit rates for devices to choose from. And really, when you're dealing with H.264 encoding, you need to think about what profile and level that you're going to employ for the video encoding. So with the baseline profile, it has very broad support, but it wasn't really meant for HD. It has poor compression. Uses more battery cycles and CPU cycles on devices. So it's not ideal, but you have a broader reach. With a high profile, like at a 4x level, you can encode and support decoding of video for playback at 1080p levels, and you have much better compression. The trade-off to that is that some of those older devices, like let's say like an iPhone 3GS or something like that, might have limited capability to decode those types of videos. On the audio side of things, it's fairly basic. I mean, 2-channel AAC is pretty much the industry standard in this regard, provides pretty fair compression levels, and you'll have super broad support for that. And on the things we've been talking about are really in the context of VOD, but for our linear channel, which is like a live channel, it's a completely different ballgame there, completely different set of rules that you have to follow and conform to maintain broadcast standard video over IP. So I want to talk a bit about our launch on a new platform. So about a month and a half ago, we launched on the Apple TV platform, and our real challenge was to take our existing HLS streams, which we used on iPhones and iPads and mobile devices and smaller screen devices, and really adapt that to a large screen, living room, lean back type of experience. So we knew we wanted to continue to use HLS, and in some of these circumstances, you have no choice to, but what we did was we took the existing profiles and really just expanded them out to provide higher resolution, higher bitrate video encodes. And we were able to implement byte range playlists without losing some of any type of interoperability by creating multiple versions of the manifest. So some devices that can't support that particular feature or subset, we use one manifest. For new devices, we'd use the new manifest, but the underlying same video, the MPEG video is still the same. And changing a manifest or creating an additional manifest is really the simplest type of approach to take in that regard, because you're not extending extra overhead. It's a 1 kilobyte file that you have to add, right? And now we're able to reuse the same set of encodes that were previously only for mobile devices. Now we use it for a wide range of devices, both mobile and living room devices. The Samsung TV app we launched the other day is also using the exact same set of encodes. But like I mentioned before, with that special type of project where you're onboarding new endpoints, it was a very big effort to then, once we decided on these rules and video encoding settings, we then had to go back and re-encode the whole catalog. But that's one thing that you hope that you only have to do once in a while and not on a frequent basis. And here's a little bit about our REST API and this is the API stack that we use to serve out the video playback access links and content to our internal endpoints, like the website, an Android device, an iPhone device. So on the left-hand side, you have we're a mixture of hybridized both cloud and physical data center. So we have our on-prem data center where we replicate SQL transactions over to AWS. We have multi-availability zones, and we heavily utilize caching clusters, an Elasticache feature. And the API webheads themselves, they're running on Beanstalk and have the capability to scale automatically. And just a summary of the workflow. So, step A is that our content providers will send us the mezzanine files or the high-quality source files. We then ingest them and encode them, and then those get shipped out to our API, and ultimately the clients on all different endpoints, be it the web, desktop, mobile, consume them and stream them from multiple CDNs. So I'm going to talk a little bit about our experience with CloudFront now. For us, it was very simple to integrate just because a lot of our encoding workflows where we're dealing with like the last mile stuff of shipping out the actual video was already being done on AWS and S3. So it's really just a matter of extending that S3 output to now be an origin for CloudFront distribution. And the competitive pricing of CloudFront was really a great benefit because when we're undertaking this little project, we had the ability to use the just go as you pay and fail fast, really. We could figure out the things that worked and the things that worked well and didn't work well and make our decision based off that relatively quickly. Another nice benefit for us was the ability to pre-warm cache for our popular content. Miley Cyrus video, everybody wants their twerking or whatever. And, we know this ahead of time. We know it's going to happen. And, we can easily spin up nodes all across different geographical regions and warm up those edge locations with that popular content. And that way, when the video release comes out, there's no real hiccups or latency in that regard. And one of the things we're able to do is actually, with our HLS and CloudFront implementation, we actually improved our average HLS video bit rate from 1870 kilobits per second to around 2200 kilobits per second. So it ultimately resulted in higher quality video for the end users without really sacrificing anything in terms of price. This was touched upon a little bit earlier, so I won't harp on it too long, but it was also very simple to secure assets with the origin access identity. So the links are only streamed from CloudFront, and we do implement our tokenization for the video playback links to make sure that they have to go through our authentication service before a user can play them. And with the new feature that was rolled out relatively recently with SSL, you can now roll your own custom SSL certs and have them at edge locations and serve content when necessary over SSL. You might have particular instances when you're embedding video on Facebook or Twitter and things like that, and those are platforms or ecosystems that have SSL enabled by default, so you really want those features available. And it was touched on the storage aspect as well with S3. The caching efficiency was really there for us, and the ability to control the amount of redundancy or the amount of nines of redundancy that you want, it makes a really compelling use case to use CloudFront in conjunction with S3 as the origin. Another important thing to keep in mind when looking at CDNs and CDN accesses, you really have to analyze your logs. Obviously, in-country delivery would be great if it was available everywhere at affordable cost, but unfortunately it's not, right? There's certain regions, Australia, APAC regions, Latin America, Brazil, where streaming costs are much higher. So it's important to know where your customers are and where your clients are coming from. And on the right-hand side here, I have a list of some of the top cities where videos are being streamed from. So in the Vivo use case, we're in 13 different countries around the world, but most of our traffic is from the US and Northern Europe. So, we can make our decisions of, I want to use CloudFront in these price classes with these price regions because it just makes sense for us. And even in certain scenarios, you'd be surprised where, we did some testing where, it was actually, on some networks, it was actually faster to serve content to Brazil out of Miami rather than in-country in Brazil just because of, some of their network architecture and infrastructure out there. So it's really something that you need to take into consideration. And this is what I was alluding to earlier. of how we were able to improve our average bit rate on iOS devices with HLS, we see that steady incline as we were rolling out this content, rolling out the new encodes and the CloudFront CDN. And it's just a steady climb there. Some of the larger concerns that us and the folks in this room that we really need to think about is the lack of standardization and the continuing fragmentation of environments is still a major issue. It's something that's not going to go away overnight. So I mean, you hear a lot about MPEG-Dash and the consortium and HTML5 video, and unfortunately there's no silver bullet, but it's important to keep these things in mind and be active in those discussions and setting the tone for those things. And it's really important to just take that initiative, at least internally, where you establish a set of standards for your own video operations. We're going to proceed with adaptive streaming protocols, HTTP-based protocols, for our video operations at least. And it helps set those standards, at least for us. And last but not least, it's very important to pick the right CDN because we've seen there's such strong correlation with buffering and loss of user engagement. It's just nowadays, people are not willing to wait for video to start. You go on a site, video doesn't start within a second. I'm going to go search for it somewhere else. So, these are all things to kind of keep in mind when you're thinking about video streaming, in this type of environment and the type of reach for your audience that you're trying to get. And that's all I have. Thank you.